Hi everyone, this is Ms. Coker. The goal of this video is to briefly review the multiplication and division problem types that students encounter in elementary school. We will specifically hone in on fraction problems that fit within each of these problem types, and we will examine some of our word problems from our Week 10 quiz, thinking about where they fit among these problem types. Let's start with multiplication. For multiplication, there are three different problem types. The first is just your typical repeated addition or your groups of problems. For example, 3 groups of 2, 4 groups of 5. The next is area problems, the area of a tiled floor, the area of a wall, the area of a garden. The last problem type for multiplication involves comparisons, where you're comparing two discrete objects or sets of objects using multiplication. For today, we will not be discussing those problems. Let's start with the repeated addition problems. We'll start with whole numbers and transition to fractions. The first example that we have here is involving two whole numbers. That would be 5 groups of 4, and that would just look like this. We have 5 whole groups. In each group, we have 4 whole things, 4 whole items, in this case, dots. Now let's take a look at what this would look like if we had a whole number of groups, but there was not a whole number of a single object in each group or a single amount in each group. So here our example is 5 groups of 3/4. So we have 5 groups, but each group only has 3/4 of a glass of soda. We could use repeated addition here, or we could use multiplication. Now let's take a look at an actual problem from our Week 10 quiz. Keith is making trail mix for his scouts. The recipe calls for 1/4 cup of M&Ms for each serving. How many M&Ms will he need for 8 scouts? So again, this will be repeated addition. We need 8 groups. Each group only has 1/4 of a cup. So we could solve that by repeatedly adding, or 8 times 1/4. Now let's go back to that language groups of for a second here. On the previous slide, we said 5 groups of 4. But if we only have one group of something, the language changes a little bit. It would look like this: 1 group of 4. And now we only have one whole group of 4. When we work with fractions, we might say 1/2 group of 4. Although that sounds a little bit different, so we probably would change our language again slightly here as well, probably to 1/2 of 4. So instead of having one whole group of 4, now we only have 1/2 of 4. And then lastly, we might have something a little bit different. We might not even have part of a whole group. We might only have part of part. So for example, here is one whole. Here's what 3/4 of that whole looks like. And I might only have 1/2 of that 3/4. The part that's overlapped with the blue and the red that looks purplish would be the amount that I would have. And it looks like 1, 2, 3. 1/2 of 3/4 would be 3. Notice that when I solved that problem, I drew all of my fourths horizontally in that same direction. Then when I drew my other fraction, I drew that vertically. This helps create a clear visual or a clear representation of this problem. On our Week 10 quiz, we had a problem related to this part of a whole group right here, as in 1/2 of 4. And the question was this: Miss B had 24 students in her class. 2/3 of the class are boys. How many boys are in Miss B's class? So this problem would be 2/3 of 24. So that actually is a multiplication problem. Now let's take a look at a part of a part problem. Taylor has 1/4 pan of brownies. He wants to give half of the pan of brownies to his sister. What fraction of the pan of brownies will his sister receive? So again, that would be 1/2 of 1/4. Next up are area problems. Let's take a look at an example. For this example, we are finding the area of a garden. If we were using whole numbers, we would multiply 3 times 12. And if we were using fractions, it would be the same thing. We would just be multiplying this time 3.5 feet times 12 1/4 feet. There were no problems like this on the week 10 quiz, so let's move on to the next type of problem. Now let's move over to division problems. There are two types of division problems that students may encounter. The first is measurement, and you can think of these as your repeated subtraction problems. And then there is partitive division problems, and these you can think of as your fair share problems. So let's take a look at what each of these. Let's start by taking a look at the measurement problems. With measurement division, we know the whole amount. For example, I might know that I have 56 pieces of candy, and I know the measure or the size of each group that I'm making, but what I don't know is how many groups I can make. So I might say something like I've got 56 pieces of candy. If I want to give each friend 8 pieces, that's the size of the group I'm giving to them. How many groups can I make, or how many people can I give candy to? You can use repeated addition to find the answer to these problems. Let's take a look at a whole number problem, and then we will take a look at a fraction problem. For this problem, it says Jose bought cheese that weighs 12 pounds. If he puts the cheese into portions that are each 2 pounds, how many portions will he have? So he knows the size of each portion he wants to make. He just doesn't know the number of portions he can make. Now, this exact problem was on our week 2 quiz. It was just involving different numbers. The other type of division problem is partitive, and that is your fair share problems. For these problems, we know the starting amount, and we know the number of groups we want to make. We just don't know how big each group will be. So for example, back to the candy, we might know that there are 56 pieces of candy, and we want to split them equally among 8 people. So we know the number of groups we want to make is 8. We just don't know how big each of the groups will be or how many pieces of candy each person will get. Let's take a look at a sample problem for this. Taylor has 8 pans of brownies left over from last night's dessert. Mom says he and his sister must equally share the remaining amount of brownies. How much will each person get? We had this exact problem on our week 10 quiz. We just had different quantities in the problem. I hope this was helpful. If you have any questions, please reach out to either Miss Belford or myself, and we will be happy to meet with you. Thank you.